Take a look at displacement reactions. So displacement reactions, if you look at the word displacement, it's when you displace, when you replace something. So basically means when more reactive metals displace, so basically replace less reactive metals. So displacement reactions is when more reactive metals displace or replace the less reactive metals in a equation, or what do you call it, in the reaction. So you could have, for example, magnesium plus iron sulfate, not iron, FeSO4, iron oxide, magnesium plus Fe. So what just happened in this reaction? Well, we have magnesium. The key things to note from here is we have the magnesium and iron. This is just the compound. The key metals in here are iron and magnesium. If we look at the reactivity series, we have our magnesium over here, and we have our iron over here, right? Magnesium and iron. Well, clearly, magnesium is higher up in the reactivity series than the iron. So this magnesium is more reactive than the iron. Watch my video on the reactivity series if you don't know this. Excuse me. So magnesium and iron. Obviously, this magnesium is more reactive. So what happens is this magnesium, it can displace. It can basically replace the iron to become FeSO4 instead. It changes. It took iron's position. And iron is just left all alone. You kind of have to imagine it like when some big bully comes. And this is the money. The magnesium is a rich bully. And it wants even more money. So you can just kick this poor iron out, take the money, and iron's just left all alone with nothing. It's a pretty easy analogy. Pretty easy to understand. So the magnesium displaces the Fe. It basically just steals the SO4 from the Fe. That's basically all you have to know. For a displacement reaction, just know that more reactive metals displace the less reactive ones. Let's take a look at one more example. We could have copper plus FeSO4. Again, we have iron. That goes to form. Think about what would happen. First of all, let me just add back our reactivity series here. Think about what would happen. Well, copper is over here in the reactivity. Wrong pen. Copper is over here in the reactivity series. It's quite unreactive, actually. And iron is up here. Iron isn't that much more reactive either, but still, iron is more reactive. So what do you think would happen when copper tries to displace this iron? Well, nothing's going to happen, because this iron is more reactive. So it just stays as it is. So it's just going to stay as Cu and FeSO4. In other words, nothing happens. No change. Because the copper is below iron in the reactivity series, so it's less reactive, so it cannot displace it. So this time when this big bully, theoretically, this guy supposedly calls himself the bully, tries to steal the money, so this will be the money, from this poor iron. Well, this copper guy is some skinny, short guy, and he's trying to steal it. I'm not trying to generalize or anything, but just it helps with understanding. This tiny guy is trying to steal this guy's money. Obviously, nothing's going to happen, so it just stays as it. That's pretty much all you need to know for reactivity, for displacement reactions. Just know that more metals can displace or replace the less reactive metals, leaving the less reactive metal just all alone, and stealing the money with the more reactive one.